Hi everyone. Thank you for joining this session again this evening. In our previous lesson, we talked about the different kinds of SQL that we have, how to get started with SQL, creating a database, how to activate the database that you have to be the current working database. And we also talked about creating a table, and we talked about data types also. I shared us a page on the data types that we have. So today we are going to continue from where we stopped. I know that the other day we created a table, books, and then we talked about author, and then I talked about constraints in our um table. So I'm going to recreate that table, that database again, just to serve as a revision. I'm going to recreate the table again, and then we're just going to do basically what we did before we proceed further. So we said the command, myself, I'm using Azure Data Studio, which is might be somewhat different from what you're using. It works the same way. The only difference is that anytime I want to execute my code, I click on the run button. But for you on MSS SQL Server, you'd click on execute. So to create a new database now, I'm gonna say create. So we talked about the commands that we have in SQL. We said we basically would be performing CRUD operation, C for create, R for read, U for update, D for delete. So we say oftentimes organizations will have their own database. What they need you to do is to query that database wherever it is and read information from that database. So let's assume that you want to start a new project and there's no database before. You just collected your data from the user and you need to create a database for it in the organization. You want to know how this database is being created from scratch. You then use the create word and the entity that you're trying to create. So in this instance now, I'm trying to create a database. So I'm going to say create database. And the name of the database I'm trying to create, mine is going to be books. So this script or this line, this block of code right here is going to create a database for me. So when I run this without any error, my code is being executed. I can decide to get rid of this. That doesn't have any effect on my database. If I refresh these databases now, you can see I now have books as my database, even though I've deleted the block of code that created that books. So, but then in my books, I don't have any table. You can see my table is at the moment empty. So if I want to create a table for this, I can say create table, just like I created the database, but this time I'm creating a table. But I need to tell SQL because right now you can see that my current working database is master. And I need to tell SQL to use books as my current working database. I told us the other time there are two ways to doing this. I could either click on this drop down here, click on books, or I could go to the top here and say views, and then the name of the database I want to use, which is books. So initially, if I have this in master, if I run this now, it's going to get rid of this in a second. If I run this now, you can see now this is now changed to books. So if I now say create, though SQL is not case sensitive, because whether I write it in small letter or in capital case, it really doesn't have, there's no difference, but it's good practice to always write your commands in uppercase. So if I say create table and I say author, if I run this now, you can see now I'm getting an error. That is because SQL expects me to tell it what structure I would like my table to come in. So to do that, I'm going to open parentheses, and then I'll list out the entities that my table is going to take. So I want my table to have an ID. I want it to have a name, and I want it to have maybe an email or something. It's not compulsory, it's optional. So now that I've defined what I want my table to have, the entities I want it to have, which is just 3, the next thing to do is to tell SQL to assign a data type for each of these. So why am I assigning a data type? This is to ensure that my database is in a clean form, clean and well-structured form, because the way you define your database will determine how your user will interact with it. So if you have created loopholes in your table or your the structure of your database, this can be prone to errors, and this can lead to lots of data redundancy, which you're trying to ensure you work with. So I want to have an ID. An ID is a number that tells me the identity number of an author. So which means if you have, for example, an author that bears Rukoya Balogun, that's worked or is written a book in the 90s, and in the early 20s, another author springs up and bears the same name, but they are different persons. Because they have different IDs, it will be easy for you to use the ID as a unique identifier to differentiate which author is what. But if you are using just their names, you could place one person for another. This is another use case we could use is our bank verification number. No other person shares your bank verification number nor your account number, because this identity is specific to just one user. I could do this one way by having to hard code the identity number myself, or I could have SQL do the assignment for me. So, but it's important to tell SQL what data type I want my user to put into this field, which is going to be an integer. So an integer, and I do not want it to be a space, which is what I'm putting in not null. Name, I want this to be a varchar, and I want it to be 50 characters long, and I also do not want it to be a null value. An email, I want it to be a varchar also, and I want it to be 20 characters long, and I also do not want it to be an empty field. So just like I said, if I wanted to hard code this, I would leave this in this manner. But if I want SQL to generate the values for me, I would use integer, then I'll say identity. So identity then takes up the function of count for me, which means the first author I put in there as a user gets assigned identity 1, or wherever I want it to start from. So if I want it to start from identity 1, I can say start from identity 1. So if I want it to then increase by 1, I'll then say 1 should be added. So the next entry should be 2, and then the next should be 3, and then thereabouts. But if I want it to start from maybe 1000, I would just say 1000 here. And then the first author would then take an identity number of 1000. The next one will take 1001. I'm just going to leave this as it is now. Now, what I've done here, I could literally hard code this value myself. I mean, I can have SQL can give me value 1 and then 2, and then I also decide to put in another author with the same identity, which I don't want. I don't want to have authors with duplicate entries of identity, because that can cause like an havoc. Because imagine there's somebody in the bank that shares your account number, that has the same account number with you, and then you share your account number with someone, and then it brings another person's name, because the system is confused and doesn't know which of the user you're trying to, relate with, if it's A or B. So this is why it's important that you don't have users have the same identity number, or authors have the same identity number in this context. So this, I'm going to assign a constraint, and a constraint primary key allows this to be a unique value. So which means when I have identity 1, no other person can share that identity 1. And that's all. Only one user can have the identity till thy kingdom come. So that being said, if I create this now, or just run this, you can see now that my table was successfully created. I'm just going to, I could either get rid of this or just comment it out like this. So to read from my table, when I say select, I told us the other day that there are keywords that we use in SQL, and that select is used to read from an existing entity. It could be a table, it could be a database, or what have you. So you can see I have my table created, ID, name, and email. So if I refresh this database now, you now see that I have under tables, and I have author, which had nothing there initially. So I don't like the fact that my table is empty. So let's just insert value into this table now. But before we proceed, before we start inserting values into the table, do you have any question up until this point? Okay, I'll assume that's a no. So let's insert value into this. So to insert value into this, I'm going to use the insert keyword. So we talked about the different commands that we have. So we said we have DDL, and under DDL we have create, we have alter, and we have delete. So before we then start altering and doing some manipulation, we should at least have values in each of this entity. But of course, we use create, alter, and delete on first level instance, like a table or a database or a stored procedure or a view, because we can only create these things, right? We can create them, but we cannot create a record. We can insert a record. So if we wanted to change the feel of our table after defining it, we could do that. So which means my table now has ID, name, and email. If for some odd reasons I feel like, oh, I want to have their maybe age or something should be a column in this table, I could, alter this table and include that. So to do that, I'm just going to say alter, and then the name of the table I want to alter, which is author. That's picking up author. And what do I want to do? I want to add a column, and the column is then going to be what? Age, and the age is going to be an integer. I do not want it to be a null value. So if I run this now, So if I run this now, permits me to make some technical blunder here, because oftentimes when you work with so many SQLs, you can like make some commands together. But if I was working with MySQL like Efe is working with, I would have to add column to it before it could work. So so now I just added age, integer column, and I just told SQL I do not want it to be empty. So if I read this again, you see that age has now been included. So I could also delete this. I could also delete this by using drop. So this allows you to alter the feel of your table, because now I created a table. I just altered it by adding a new column to it. I could also delete the table if I wanted to. So to delete the table, I will say delete. But then I'm not deleting the table. I use delete to delete an entry. I actually use drop to delete an entity. So the right word should be drop, not delete. So if I say drop table and I say author, this keyword is going to delete the author table, completely delete it. So if I run this now, you can see, and when I run this author again, I don't have an author table again. But if I want to rerun this, I'm just going to rerun this like this, and then run it again. And now this is very much active. So always ensure that when you are using the drop command, you are using it for the entities that you really want to get rid of. So now I'm going to move on and talk about DML, which is data manipulation language. Under data manipulation language, I have inserts, I have updates, and then I have deletes. So the question you might want to ask me is, what's the difference between this drop and this delete? They basically mean the same thing, because drop and delete, they delete the same, they get rid of values. But the drop here is on a first instance. For example, you want to drop a database, you want to drop a table, you want to drop a view, or a drop procedure, or something like the CTE or something. But you cannot delete, you cannot use the delete word. You cannot say delete table like this if this would not work, because delete is used for a different purpose. For example, you have an entry in your table, you want to delete that entry. So that's like a second level instance. So that delete can be useful for. But if you want to delete a first instance case scenario, like a table, a database, a view, or what have you, you use the drop keyword. But if you want to remove an entry from your table or what have you, you use delete. So let's insert into our table. Let's update that entry, and then let's try to delete that entry. So to insert into my table, I'm going to say insert into the name of the table I want to insert into, which is author. And then in what order do I want to insert into it? I want to insert into it using the name and the email. So you can say I'm not specifying ID, because my ID is an automatic, get an automatic generation from SQL. So I don't need to manually impute that. SQL does the impute for me. So if I say value, and then I start inserting my values here, maybe William Shakespeare or something. If I get that correctly. And then the email, I'm just going to say will s at gmail.com. So let's have a couple of other entries. I'm just going to say, who else do we have there? I'm just going to put in random names. I'm going to say ABC something, ABZ. Then I'm going to have AB at Gmail, just using random stuff. So just going to end this. It's good convention to always end your commands like this. So I'm getting an error. And what is the error I'm getting? It's telling me that I have inserted, there's an incorrect syntax near ABZ. It's not really the ABZ that has the incorrect insert. It's that I did not separate this value from this value. So this is one value. This is another value. So in between, I'm supposed to separate each value by a comma. So that is where the error is coming from. You can see that the angry, annoying, coily sign is gone. So if I highlight now and I click this, you can see I have two rows affected. So which means I've successfully inserted two rows. So I'm just going to copy this guy here and paste it right here. And then I'm going to run this right here. So you can see now that I have William Shakespeare. I feel like the spelling is wrong. And I have ABZ. So, but I did not insert the ID myself. You can see that SQL has done a pretty good job by inserting the ID 1 to the first entry, 2 to the second entry. So I didn't have to do that manually myself. But let's try to, hard code the ID and let's see what happens. So I'm not a writer. I've never written a book, but let's just say that all of a sudden I'm writing something out of the blue moon. Let's try to have one more entry here. And I'm going to say I am SQL. I now want to hard code my ID into this place. And I want to take, sorry, can you say that again? So for some odd reasons, I now want to hard code my identity number in there. So if I'm just going to say RB, that's not my Gmail. You can try to reach me using that. rb@gmail.com. So if I run this, I get an error. And what's the error? Cannot insert explicit value for identity column in column author when identity insert is set to off. So which means that what this is telling me is that I cannot add code identity number because I've already told SQL to be the one to insert this identity number for me. So I can't be the one to hard code this myself. So it's not possible that I then say I now want to put my name in number 1 because I don't like William Shakespeare. That doesn't make sense, right? So if I run this on its own, my entry gets accepted. And if I run this again, now I have 3 entries, right? So let's say that for some odd reasons, I figured that this ABZ is not a full name, and I want to update this record. At least we all have first names and last names. So why is this person only having, just one name? So I want to update this person's record so that they now have a full name. So I'm going to use the updates to do that. Don't forget that when I wanted to update or change the value on the table side, I used alter. When I want to change the value from the row side or the record side, I use update. So to update my ABZ now. I need to look for something that is only particular to ABZ. So it could be an email, it could be the ID. Two persons might be sharing, no, two persons cannot share the same email address. I'm very sure about that. And I also know that two persons cannot share the same ID. So I can use either of these to be the unique identifier. Because if I don't have something that is very particular to this person, SQL is going to change all the records that have that satisfies that condition. So what do I mean? So I want to update now. So I want to update a table. The name of my table is author, right? And I want to set a value. I want to set name now to let's say something up to Zahir or something. I don't know. Let's say I want to set this. If I run this now, I'm not going to run it, but if I run this, all these names get set to Abdul Zahir, which is not what I want. But then I only want this one to be changed. So I need to look for something that is only particular to this person. So I'm going to use a where clause and say where my ID is equal to 2. So there's only one user that has an ID equal to 2, which is this person here. Or I could say where email is equal to AB, Gmail, or whatever I have there. So I can either use it like this or use the ID. So you can now see I have one row affected. So if I run this again, you can now see that I was able to make that effective change where I want the change to occur, really. So, but if I had actually executed the code like this, all the names here would have been changed to this guy right here, which is not what I wanted. So the same thing I did here, I could also use to get rid of a record. Let's say we want to remove all the persons that have a certain name from our database, maybe Balogun Rukayat or something. I want to remove all the entries that have that, even though we have just one entry there. So what I want to do is what? I want to use the delete keyword to get that, to make that happen. Just going to say delete, although, and I'm going to remove this set, and I'm going to say where. I could use a name or I could use an ID. So this time I'm going to use an ID. I'm going to say where ID is equal to. So if I run this now, only one row satisfies that condition. And if I come back and run this, you'll see now I have just 2 entries. The last person has been deleted because it was only that record that satisfies the condition I specified to delete an entry. Does that make any sense? Are you here, Christian? So that being said, we have talked about how to define data definition language, which is how to use the create, alter, and drop. We've also talked about data manipulation language, which is how to use insert, update, and delete. The next one is DQL, which is data query language. And data query language only has one command, which is select. So in this particular one, I would be using Adventureworks database for this one, because this allows me to really explore the database more. So I can walk you through how to download and upload Adventureworks into your current working environment. I'll attach a link to that in the description. But let's see how we can use the select statement to read from our database. So the first thing I'm going to do is I'm just going to change my database from books to Adventureworks. And then the next thing I'm going to do is to tell you the number of columns I have in my database. So to do, sorry, number of tables I have in my database. So to do that, I'm going to say select star from sys.tables. Sorry, tables. So what sys.table does is that it tells me the list of tables in my current database, which in this context is Adventureworks. So I have quite a whole number of, I have 71 tables here. If we could just click the, if I click on here and then I click here, you can see the full description of the table with their schema just right beside it. So let's start reading each of these tables. Let's read some of the tables, not all. Let's read some of these tables. Let's get familiar with what we have in this table and how we can create a custom read of what we have in these tables. So I'm going to be picking the person table. So to read this, I'm going to say select everything from person table. So this is what we have in the person table. So the person table includes the first and the information about the employees in a particular organization. So adventure data, this Adventureworks is a sample database. It has quite a whole number of table to work with. So this person table is a table that talks about the employee information, the person type, if this person is an employee, the title, if they are married or not, their first name, their last name, their middle name, the email promotion, and that's just about it. So now we can now start creating a custom select of what we want to read from this table. So the first thing I want to do is I want to know, is it just employed data type that we have here, or we have further information I'm actually interested in. And sometimes I don't want to read records that have no values. I want to filter this part out. So we can start creating custom select. So if I wanted to select just the first name, the middle name, and the last name. So what I've done here is that I told SQL to select everything from the table person, that person. So that's what this means, because asterisk or star, asterisk, however you want to put it here, means everything. But you can have a custom select where you only select some columns that you are only interested in. So to do that, I'm just going to say select, and then the column name in this context is first name first, then middle name, that's when person what person title. I highlight and run this now. You now see that I only have first name, middle name, last name selected from the table. And before I had like about 10 to 15 columns. I had 13 columns, and now I'm only reading 3 columns from here. And from these 3 columns, I could still, read more. I could still refine it down more. So from this now, I'm having about 19,000 records, 19,972 records being selected. I can still filter this down. So I'm just going to say this has 19,972. So let's say I only wanted to select the ones that had their last name to be Zimmerman, right? I could do that. I can say select the first name, last name, middle name here, where the last name is equal to Zimmerman.
Light. Light.
Sorry? So if I run this now, I'm just going to see I have 13 employees have their last name. So we have a whole family here. 13 employees have their last name to be Zimmerman. It could be that they are not related or something. We don't know. But we don't have duplicate entries here. So we are having Jack, Janie, Joe. I can specifically say that this J. I don't know. It's just a hunch. But it could be that they are from the same family. It could be that we don't know each other from either. So you can see that this is giving me 13 entries, right? So I've been able to narrow down my search, and then I'm getting 13 entries from here. So I could also, rework this to remove all the null values, right? You can see I have a whole quite of null values. I'm seeing Adam, I'm seeing all of this, right? So I can rework this to not show me null values. So I'm going to say this, and this, where middle name is not null. So if I run this now, you can see now that my 19,972 records is now being skimmed down to 11,000. So what that means is that I had 8,000 names had their middle names being null. So null means it's empty. So that's what that means. I had 8,000 entries being null values. So I could also, read more. I could say, give me names of people that starts with maybe A, or give me names of people that starts with a certain letter or that has a certain character in their names. But before we proceed, do we have any question up to this point? Now, in the absence of no question, let's try to get some names that either start with a particular letter or have some, letters in between or thereabout. So I'm just going to paste this again, and I'm going to write a where clause. So basically, my where clause is just saying only return records that satisfies this condition. So which means that if the condition is not satisfied, please do not return that record. So I'm going to say select all first name, middle name, last name from this table where the first name like. So when I say like, I'm saying where the first name matches this pattern I want to put down. So when I say the first name start with A, can have any other value. That's it. That start with A. Just going to run this now. So you can see now that I have records that start with A now. So I'm only having the records of all entries where the first name start with an A. And I have just about, how many records is that? About, let's say, 2014 records have their first names in A. So if I say I'm looking for a particular person, maybe the person is A, but maybe ends with name Y or something. If I run this now, you can see I'm having somebody has a name that has, I'm saying return the record of people that have in A starts their name and then Y ends it. So let's say I'm looking for a record, but then I don't know the name of the person, but I know it starts with an A and then it ends with a Y. You can see that I'm having lots of Amy, Ashley, Audrey, Anthony, and a whole lot of that Ashley, AJ, and stuff, AB, Audrey, and stuff. So this is to say that I'm saying start with an A. This percentage sign represents a wildcard, which says it can have values in the middle, but it should end with a Y. We can also have wildcards that signifies the position of the entry. I'm just going to get rid of this Y for a second. Just going to copy this, paste it right here, and then put a Y to it. And then often at another time, I can say that if I can see Amy here and I can see Andy or something. So let's say I'm very sure that the names start with A, and then it's just one letter before the last one, but I don't know the letter, right? I can say maybe, just gonna paste this right here, and then I'm gonna say underscore and then Y. So what this would do is that this would only fill in one letter in the middle. I'm saying there's just one letter missing in the middle. I don't know what letter it is. So I just wanted to fill in, it'll return all the names that start with an A, ends with a Y, and then has just one letter in the middle. So you see that it returns Amy because that's the only one that satisfies this condition. So we've checked the ones that start with, we checked the ones that have names in between. We could also check the ones that ends with. So to check the ones that ends with, still using the same context, I could say, I'm just gonna copy these parts, and I could say maybe this one. So in place of having a letter end like this, I can say return a name that ends with a P if we do have, or we have. So we have them Phillips and stuff there. So I'm saying, I don't know what the name is gonna start with, but I need you to return all the names, first names. I need you to return all the names, but use the first name that ends with a letter P. So you can see J. Philip, you can see Sandeep, you can see a whole lot of these names popping out. So another thing you could do is to also check if something ends with, which we've also looked at. We've checked if it ends with something and then it start with another thing. What if we wanted to combine these two characters together? Just gonna run this now. So I want to say, for example, now Philip, I want to say maybe I want to say the name start with a P, right? And then I can say I have one Philip here and I have Philip here also. So I can say two characters in the middle, right? So which means P is there, HI is there, and I say L. L is there also, or I could just say put an ampersand here. So what this means is that I'm saying return all the names that have P started, and then they have two other characters and they can have other values in it. But if I remove this, I'm saying just two characters ending it, right? So that's P and then 80 because I have two character space here. But if I'm saying two and then a percentage sign, I'm saying it can have more than two characters ending it. So you can see we have Pilar, Paul, Paige, Paula, Pedro, Peter, Priscilla, Paige, and stuff. So do we have any question up until this point?